All right, welcome back, everybody. Back 21. One last question we're gonna wrap up 6.1B. That was on discrete random variables. And this was, remember, expected value was the sum of x times p of x. So I wanted to go over an example that had life insurance. The life insurance problem. So a lady pays $530 annually for life insurance. For a $250,000 life insurance policy. Looking at people in her age bracket, health, smoking, weight, all that good shit. Probability of survival. It's pretty good. It's 0.99791. Our goal is compute E of X for the insurance company. Now, remember, E of X is expected value. What does the insurance company value? They value their money. So that's gonna be, our X is gonna be related to money. So let's make a little table. So what are the possible outcomes in this scenario? Not numerically, just think about what could happen. She dies or she lives, right? Maybe let's label a row lives or dies. If she lives, what does the insurance company get?
They get her money.
They get her money, right?
Yeah.
She paid $530. And they didn't have to pay shit out. So if she lives, they get $530. She dies. What do they get?
And it was two.
They gotta pay $250,000, but they already collected the $530. So they keep the $530. They're really only down $249,470. That's the tricky part of the life insurance policy. It's easy to forget about how they already got the money. They don't give out the insurance for free. So you gotta pay for it. So what are the probabilities associated with this? Which one do we know? The live column or the die column? Live, survival means she's alive, right? She survived, she's alive. So that is 0.99791. What's the probability of death? They didn't tell us this, did they? Well, what do we do now? The probabilities have to add to 1, right? So 0.99791 plus question mark is 1. So question mark is 1 minus that. This is like the event and event complement. Oh, 209. Practice. I didn't start doing big numbers in my head. I started with little numbers in my head. And you work your way up.
That times table.
I started doing, like one night I couldn't sleep and I'm like, let's see how. What's the biggest number that you can compute squaring it? Like I knew squares up to like 13. Like 13 square. 1 through 10 are on the times table. They're literally the diagonal on the times table. If you know that your multiplication table for 0 to 10, you know your square is up to 10. 10 squared. 10 times 10 is 100. 9 times 9 is 81. They're the fucking diagonal. It's not, but doing the other ones, I think I got up to 30 something before I was ready to go to sleep. And I figured out a better way to do it. Rather than just trying to fucking multiply it, I started factoring them. I got better at math trying to fucking, yeah. That goes there. So we need x times p of x. And when we add them up, that will be expected value when we add them up. So 530 times 0.99791. I'm getting, and I'm only gonna do 2 decimal places because we are talking about money. If I do 240, negative 249, 470 times 0.00209, I get negative 521, 39. So if I add those up, what do I get? Or subtract.
Can't even talk.
What, Arturo?
My bad. Hey, I thought I couldn't talk. My fault. I was
Oh,
gonna
shit.
answer it.
Shit, he found his mic button.
Fuck, I did.
What is it,
All right,
Arturo? Said you're gonna answer it, I ain't done it yet.
But what are we doing? 528?
I'm adding these 2 up. I know someone already said the answer, but he did want to participate, so. I'm gonna let our
1,050, 28.
What?
1,050, 28? But that's negative though, so I'm fucking wrong
That's
anyways.
negative, there's no way that.
Yeah, my fault. My fault. There you go. Ask Krista.
Someone already said it was $7.50, you got the wrong answer, you already lose. So. Expected value per policy. Is only $7.50. But let's say they have 1 million customers. Well, their expected profit goes up. It's now 1,000,000 times 750. Which is $7.5 million. Even though the annual policy is 530, they gotta pay out enough. And that $250,000 is quite the hit when you're only making $530. They pay out enough, but it's enough that they make a profit on every single one on average. And with enough policies, you make a lot of money. This is how life insurance policies work, this is how your warranties work, like you buy electronics, they're like. 3-year warranty for so and so dollars, they've calculated the expected lifespan of the electronic product. They always do the warranty for a period that's shorter than that. Like if they think it's gonna last 5 years, they'll say 3 years. Cause some of them some will break before 3 years, you'll have bad apples in there. But like the probability of the electronic breaking in 3 years when the lifespan is generally 5 is really low.
You waste your time.
Well, it's always a waste of money if your thing doesn't break. You're not buying anything other than the reinsurance that if it does break, you don't have to buy a new one. And generally, like on like a phone, that warranty isn't really that much. You know, like on a laptop, it can be a couple $100. Might be $150 on a laptop to give a warranty for 3 years, but. Overall, they're not making a whole lot per warranty, but they are making money. That's the end of 6.1. I'm gonna stop the video and start a new one, so it says 2 different recordings.